Good morning. Excellent. It's my pleasure to be with you today to think together a little bit about what the future of AI is going to look like and try and draw a line between, some chaos that we're fearing and the wonderful sort of promise that AI might have, that if we can push it in the directions that we want it to do, it might do really amazing things. So let's start with the chaos part. We're already seeing a little bit of this, right? When I thought about doing this, I thought, I'm going to go, my lab has a repository of the risks that AI is posing, and trying to understand, okay, if you're a business or an organization trying to deal with AI, okay, what comes up? And one of the things we can do is we can look at particular types of risk and we can say, what are the incidents we're already seeing coming up in the news? Well, we see some very sad moments of chaos, right? In Uttar Pradesh, we have a car going off a space where a bridge used to be. But it turns out that the map that it was based on, that the car was self-driving on, just didn't have the fact that the bridge had been washed away. And so some people died. Very sad. We also see some cases where, people did have command of the AI, but unfortunately, they didn't use it for good. So this is a case where a Mumbai businessman was defrauded by being called and using a deep fake to report to be his son, report to be somebody from the embassy, trying to get him to give over 80,000 rupees. Okay, so we are already seeing some chaos. But maybe what's surprising about this, given that how much we see AI in the news, is that we don't see more chaos. And the question is why? Right? Why haven't we seen this? And the simple answer is, so far we haven't had it because these systems have just not been capable enough to get to that level. Okay, so let's unpack that a little bit together. So the first thing to understand is that AI really is a big departure from traditional IT systems that we've had, right? So if you think about some sort of thing of some kind of tasks that you might want to do and how well these different systems can do, you can think of traditional IT, something like Excel, right? For Excel, there's some things it does really well. If you ask Excel to multiply some numbers, it's going to be perfect at getting that. And if you ask it, what shall I have for dinner tonight? It's not going to be very good. But with AI, you get a different pattern, right? If you ask AI to multiply some numbers together, it will usually get it right, but not always. So it's a little less good. But if you ask it what to have for dinner, it will often tell you, something. Maybe a good answer, maybe a bad answer, right? But it will give you an answer. Now, it turns out that this distinction matters a lot. Because for a traditional IT system, the fact that you have this area where it's basically 100% correct means that you can stack these systems one upon another, right? So you can gather some data, you might put it in a database, you might do a query of that, all of those kind of things. You can put them one on top of another, and you get 100% and 100% and 100% and so on. Well, what happens if you take an AI system that isn't perfect and you stack it one upon the other? Well, the problem is these errors are going to stack as well, right? And I call this the idea of AI's garden of branching paths. So think about this as like the AI starts when you ask it for some particular thing, right? And one of these paths is going to lead it to the right answer, and a lot of these paths are going to lead it to the wrong answer. And each time it gets to a branch, it has to make some decision, some internal calculation to say, this is the right answer to your problem. Well, of course, the more times you have that branching, the more likely it is to go off on the wrong path and give you the wrong answer. And in fact, when OpenAI has estimated this for ChatGPT 5, what they found is that 5 to 12% of all of the queries that they give have an error in them. Okay? So this is sort of with the typical number of branching paths that you actually have for the queries that they're being asked. So what happens if you want to go further? Right? What if you want to say, well, I don't want it to just do the things people are asking today, I want it to do really autonomous things, right? Things that might take it a week or a month for it to do. Okay? What does that look like? Well, it turns out there have been some really beautiful work this year by some of the researchers at Meter, and they found the following graph. Okay, so what we're looking at here on the x-axis is how much time it takes a human to do a particular task. right? And you can imagine that as the amount of time it takes a human gets longer and longer, that means that sort of like more and more decisions are having to be made to get to the right answer. And then on the y-axis, we have how good these systems are at doing it. And what's remarkable here is when the task is very short, these systems are very, very good at it. Now here it looks like it's about 100%. That's just because the sample is pretty limited. As we just said, there actually is going to be a little bit of error. It's sometimes going to make a mistake. But it's quite good when you're talking about things that take humans 10 seconds, a minute, something like that. You can see, as you get to things that take humans 2 days, a week, or something like that, these systems are basically terrible. They almost never get the right answer. Okay, so this starts to allow us to disentangle this idea that some of these things they're able to do very well, right? You can ask it to generate an image, something like that, pretty quick. If you ask it to do sort of a large scam against someone, like lots of pieces of that scam, it will probably fall apart if it's going to take a long time. So this, in fact, has protected us. Right? This has meant that these capabilities have not been good enough to make these systems very autonomous, right? And that's, of course, the thing you'd really worry about for a lot of chaos is if these systems could be very autonomous, get out in the world and do all kinds of things. But this is changing very rapidly. So what do I mean by that? Well, on that last graph I showed you, there was sort of that region of like, things were really good. And there's a region where things were not good in terms of performance. And then there was a middle region where you said, we're just transitioning, right? These systems are just getting good enough. And so this same paper by these researchers, they said, well, let's look at that middle ground and how it's improving and think about how that looks over time. And what they find is this. So here what we're showing, on the far left, you can see some of the early systems like GPT-2. As we get to the right, we have more modern systems like Claude 3.7. And what you can see here is on the y-axis is that, again, that how long it takes a human to complete the task. And notice, we're getting better very fast. In fact, yesterday we heard from Rishi Sunak that exactly this idea of these capabilities improving every 6 to 7 months, that is this chart. This is what it is showing you. So this is pretty remarkable, right? This tells us that it will not be that long until these systems are able to do things that take considerably longer to do, and therefore we'll be able to give them more autonomy. And that poses some risks. Now, you might ask, okay, well, if these systems become more capable, maybe we're going to be able to control them, right? We will have these things to control them to make sure that they're only doing the things we want to do. And unfortunately, so far, we actually don't have good evidence that that is the case. As these systems become more capable, they actually it becomes easier for them to circumvent some of the things that we want them to do. Not everything, but some of the things that we want them to do. And so we've tried lots of things. People have tried, having AI watch AI, right? Maybe that can help us do it. It can help in some cases. We still don't have it. So as of right now, we still don't have any guarantees that as we get to these greater capabilities, we're going to be able to have more control, right? And so this is just, for any of you who are policymakers in the room, I want to encourage you, give your companies, give your researchers in the country more money to study this question because, there is promise. There are very small windows where we can show that we can actually do much better prediction, but it's very, very limited at this point. And as we just saw in that last chart, these things are going to move so fast that if we wait until we get to the point where all of a sudden, something bad has happened, things are going to keep moving very fast. We need to prepare for it ahead of time. Okay. So to think then about, well, if we can't get a lot of control, it's going to actually matter a lot how these capabilities develop, right? How fast are these things going to happen? And what is it going to mean for us? And so to do that, I want to take a second to talk about how we've gotten to the current moment in AI. So it turns out that there are basically 3 factors which have been the things that have driven AI forward over the last 10 or 15 years. The most important of those is just having more chips and running them for longer, right? I'm sure this is true in India as well, right? In the United States, we see data centers going up all over the place, right? Huge demands on the energy system, precisely for this reason, right? And it turns out this is one of the most important facts in AI, is this idea of something that's called the scaling law. If you haven't heard about a scaling law, don't worry. What it is a recipe. It's a recipe that says, if you want an AI system that has a certain level of capabilities, I will tell you, if you use this amount of data, this number of GPUs, put those together, you'll be able to get to a certain level of performance. And that is the recipe that all of these companies have followed. OpenAI, Anthropic, all of them have said, we're going along this path, and they've scaled up enormously. And of course, we've had enormous data centers as a result of this. This has been by far the dominant way that we have gotten better AI performance so far. Now, there are some other ways. We can have more efficient algorithms. So imagine AI is a computer program, like a lot of other computer programs. It's going to do a series of steps in order to do it. It turns out that as we either train these systems or as we do inference with them, the actual using of them, there's actually some inefficiency often in the way they're designed, right? So I've sort of drawn that as this circuitous route that you're doing to go from A to B. So that means that if we can think cleverly about it, right, we might be able to go more directly. And so you may have heard about this in the context of DeepSeek, right, which was sort of the famous one we heard about. A lot of what they did was a lot of clever little things in order to get performance improvements so that fewer GPUs could do the same thing as somebody else using many more GPUs, or a smaller model could do as much as someone else doing more. Okay, so this is very interesting, right, because this is really efficient. This means that our systems become more capable. The third source, which is by far the least important of these three, is more efficient GPUs. We had, successive generations of chips get better. Now, this was actually the dominant way that we got performance improvements before AI, right? If people know about Moore's law and semiconductors getting better, this was sort of the dominant thing. It's interesting that in AI, it's really the third of these. It's the one that's by far the least important. Okay, so why have I told you about these different sources of improvement? Well, the big reason is because what's going to come next matters a lot whether we continue on this path of the thing at the far left or whether we go in the middle. Is it the more chips or is it more algorithms? So how does that play out? Well, if we have more chips for running for longer, that means we need to scale up, right? And one of the things about getting better performance by scaling up is that every last little bit that you try and get costs you more and more to get. There's just an incredibly expensive thing. That last little bit of performance, squeezing it, takes a huge amount of processors. That means that if this is the dominant way we get, what we're going to get is very expensive AI, right? You might have systems that could cost $10 billion to train, but only a small number of people will have them, right? Because they are so expensive. What if that's not the dominant way? What if what actually happens is more efficient algorithms? Well, if that happens, then what quickly happens is as soon as performance comes in at a top level, so you have some very powerful model that can do something, within just a few years, even very small models, like the kind you might have on your phone, can be capable of incredible things, right? Under that world, we get a decentralized, inexpensive world. Now, that's a great world in terms of productivity, right? That's a world where we say we can deploy incredibly capable AI systems all over the place. It's also a world where we have incredibly powerful tools in a huge number of hands, and that's going to pose a lot of challenge for control, for security, and things like that. Okay, so the key message I want you to take today is that AI's lack of capabilities is really what has protected us from a lot of the worst outcomes we might worry about. That has protected us, but it is changing rapidly. And we just have no guarantees that as we build these more capable systems, we're going to be able to control them, right? And so that's something we need to invest in. We have these little examples of what we're trying to do, but there's a lot yet that needs to be done on this. And so what this means is that in practice, what's going to happen is we're going to have to sort of manage these things as we go, and what's going to determine that is the capability path. Is it going to be scale up to even bigger data centers, even bigger models? That's centralized, you can imagine sort of regulating a small number of people. Or is it going to be very decentralized, we're going to have it all over? Some work that we've done suggests that that latter one is much more likely. And if that's happened, we call these the meek models. If meek models inherit the earth, that means that there's going to be a lot of productivity benefits, but also a lot of risks that are going to come along the way. All right, thank you.